All right, here's 4 questions from the uh, um, review, final exam review. First one asks you to simplify this. So they basically want you to use whatever exponent rules you can in order to simplify this expression. One thing I would do maybe before you look at this last one is maybe simplify what you have inside here. There's 2 on the top here, but there's no number underneath there other than 1, so you can't really change that. But x cubed and x to the 5th, those are like bases. So if you're dividing, you can subtract exponents. So you'd have a 2, and then you'd have x to the 3 minus a negative 5, right? That's where those come from. And since you're dividing, that's where that subtraction there comes from. And then you have y to the negative 3 minus 2. Okay, and so that takes care of those x's on the bottom. And then you have up here, you have a minus 4. Okay, so then you have 2. 3 minus a negative 5 would be 8, so I'd have x to the 8th. And y minus 3 minus 2 is negative 5 to the negative 4. Now, so that is, I use the quotient rule to simplify these. And now I can use the power rule to take that negative 4 and apply it to everything inside. So it'd be 2 to the negative 4, x. So this is power of a power, so I'd multiply those. So it'd be 8 times negative 4, or negative 32. And y to the negative 5 times negative 4 is positive 20. Now this is the y to the 20. I think that's the only one that sort of looks like it's in an end form. These ones have negative exponents, so I can slip those to the bottom of a fraction. And so the 2 would go onto the bottom. Right now it's on the top of a fraction. If I slip it to the bottom, the exponent becomes positive. And same thing with the x. It'd be x to the positive 32. And the last thing I would do with this is I can figure out what 2 to the 4th is. I think that's 16. And there I would leave it. I can't do anything with this because one's a y and one's an x, so I can't simplify that. And so this is where I would leave that question. Okay, question 5, it asks you to use the sum or difference of cubes to factor this. First thing before you use the sum or difference of cubes, and that rule looks like this. A minus b cubed is equal to a minus b times a squared plus ab plus b squared. So if I have 2 things that are cubed, I can factor it into that form. So, but this one, I have a 2 out here, and that bothers me. But both those terms have a 2 in. So I could factor that 2 out, and I'd be left with u cubed minus 8. And 8 is the same thing as 2 cubed. So now I've got something here that looks exactly like this, except there's a's and b's or u's and 2's. But I can simplify it, not simplify, I can factor it. So I'll leave the 2 out front, and then I'm going to have a small bracket and a big bracket, and I'm just going to sort of follow the pattern. So it'd be u minus 2, then u squared, plus u times 2 would be 2u, plus 2 squared, which would be 4. There. And that would be the factored form of that using the difference of cubes formula. Okay, next question deals with lines. It says determine the equation line described. So the line goes through negative 2, 7. Let me maybe just put out a, whoops, let me put out a quadrant. There we go. So we've got a quadrant here, and they say it goes through negative 2 and 7. Oh, that's a point right there. And then, and it's perpendicular to this line. So if it's perpendicular, it means that the slope is the negative reciprocal of this one. So this is sort of my line information. This is my stuff. And this over here will do information that's perpendicular to my line. And really from this, all I want to get is figure out what my slope is. So to do that, I can change the equation, and I want to get it into the y equals mx plus b form. So I'm going to leave 9y there. I'll add 7x to both sides. Then I'll divide both sides by, or every term by 9, because I want to get the y by itself. So I'll get y is equal to 7/9 x minus 49 over 9. Okay, now this would be the y-intercept of the perpendicular line, not my line. That's the perpendicular line. This is the slope of the perpendicular line, but I can get from that my slope, because my slope of a perpendicular line will be, you flip this over and change its sign. So it'd be 9 over 7. Right now this one's positive, so mine's going to be negative. Now that I have that information, I can use the slope and I can use a point that's on my line. That one's on my line. And I can use it to write an equation. So here's the equation. Y equals mx plus b. I know the slope is negative over 9 over 7. I know an x value up here is negative 2. And I know a y value is 7. So here I have an equation where I can solve for b. Let's first multiply this stuff together. That'd be 18 over 7 plus b is equal to 7. And then I'll subtract, I'll subtract 18 sevenths on both sides to get the b by itself. And then 7 is the same thing. Let me go down a bit. 7 is the same thing as 49 over 7. You could do this on your calculator too. Equals b, so when you subtract that, I think that gives you 31 over 7. That's the slope, or the y-intercept. Now to write my equation, again, is the y equals mx plus b. The slope I know is negative 9 sevenths, and the y-intercept is a positive 31 over 7. So there's the equation of my line. It has my slope in it and has my y-intercept. All right, the last question deals with logarithms. And you want to use the laws of logarithms to simplify this. There are lots of different ways to do it. Probably what I would do is change that radical to a fractional exponent. So I'm going to leave x7 over x6, z to the 9th. And rather than being a third there, I'm raising it to 1/3. Okay, and it's not really a log thing. That's just you can do that with radicals. And then this is a power of a power with exponents. So I can apply that 1/3 to everything that's inside. So I could write log base b of x to the 7/3 over x to the 6/3, which is 2, and z to the 9/3, which is 3. Okay, now I have to change it into sums and differences. So now you need to use the product or the quotient rule. So here I'm dividing by something, so that'd be the quotient rule. So that would mean I would subtract both things on the bottom. So when I write this, use those rules, I'd write log base b of x to the 7/3 minus, and the minus comes because we're dividing by these things on the bottom. So minus log base b of x squared minus, again, because it's on the bottom of that fraction, log base b of z cubed. And the only last thing that I would do is maybe use the power rule, where I can bring those exponents out to the front of the term. So I'd write it as 7/3 log base b of x minus 2 log base b of, oh, is there supposed to be a y in there somewhere? Oh yeah, this one's supposed to be a y. Minus 3 log base b of z. All right, hopefully that helps with those 4 questions.